Let's now go into our first coefficient, that is coefficient A. Coefficient A is a deviation which remains constant in name as well as magnitude on all the headings and is further divided into two parts. These two parts are number one, real A, and number two, apparent A. Now, if you remember the formula which I had shown you, the formula for deviation, in that formula we saw that this coefficient A is not connected with the ship's course in any way. Indirectly, that means that whatever be the course of the ship or whatever be the heading of the ship, the value of coefficient A is not going to change. And you see exactly that is what the definition also tells us. Coefficient A is a deviation which remains constant in name as well as magnitude on all the headings. The vessel can continue to change its heading, and the deviation which is generated because of coefficient A does not change at all. It has two components and it can be divided into these two components. One is called as real A, another is called as apparent A. What is this real A part of the coefficient A? It is a constant deviation on all the headings caused by induced magnetism in unsymmetrical pairs of horizontal soft iron. I will explain this to you in detail by showing this kind of structure in the diagram. So for now, just understand it is caused by induced magnetism in unsymmetrical pairs of HSI, horizontal soft iron. So the cause of real A is the horizontal soft iron on board. The second part, which is called as apparent A. Apparent A is a constant deviation on all the headings, which is caused by factors other than the magnetic field. So beta, before I proceed ahead explaining these, any doubts up to here?
Yes, sir. This real A and apparent A has not cleared, sir.
Okay, अभी clear हो जाएगा बेटा. Let me now show you the kind of structures which may generate coefficient A on a particular ship. Now we have seen that coefficient A is generated because of unsymmetrical pairs of horizontal soft iron. Now horizontal soft iron HSI can be present in two orientation. We can have a fore and aft horizontal soft iron, something like this one. This is horizontal soft iron in the fore and aft direction. And we can also have horizontal soft iron in the athwart ship orientation. You now see another horizontal soft iron which has a athwart ship orientation. So the first thing to note is that coefficient A require a pair. Pair means there should be a combination of fore and aft as well as athwart ship horizontal soft iron. The second thing which is required is that these horizontal soft iron should be unsymmetrical. Now, what do we mean by unsymmetrical? If you look closely, the fore and aft HSI which we have is present only forward of the compass location. The circle which you see in the middle of the ship is representing the compass, the binnacle, and the HSI in the fore and aft orientation is only present forward of the compass and it is not there aft of the compass. This kind of a HSI is known as unsymmetrical HSI. Likewise, this athwart ship HSI which you see is present only on the port side of the compass and it is not present on the starboard side of the compass. So both these HSI are unsymmetrical. That means they are present only on one side of the compass and there is a pair present, means both fore and aft and athwart ship HSI are present. This kind of a combination, if it is present on a ship, will generate coefficient A. Now, usually we do not see any kind of these structures on a normal merchant vessel. You will always have symmetrical HSI. So that is exactly the reason why coefficient A is absent on most of the normal merchant vessels. Beta, doubts up to here?
So then what would be an example of symmetrical pair of HSI?
Symmetrical is the usual fore and aft longitudinal and athwart ship beam beta. It is running from bow to stern and beam to beam. That would be symmetrical about the compass.
So basically it goes forward of the compass and after the compass, and port
That's
side of
right.
the compass and starboard side of the compass.
That's
That is
right, beta.
symmetrical.
That's
Okay.
right. Okay.
So these are caused by the rods.
Beta,
It,
these are the structures on the ship, fore and aft longitudinal and athwart ship beam. इनको मैग्नेटिज्म में रॉड के साथ भी डिनोट किया जाता है, but we don't need to go into rods for our explanation.
okay, sir.
Okay.
Sir,
But
ये unsymmetrical pairs.
Yeah, go ahead, beta, one by one.
Pratik, you ask first.
सर ये ऐसे स्ट्रक्चर अभी के शिप में तो नहीं होते हैं, करेक्ट?
नहीं होते हैं बेटा, नहीं होते हैं, बट हमने जो मैग्नेटिज्म डिस्कस करना है, वी हैव टू एक्सप्लोर ऑल द पॉसिबिलिटीज, सो दैट्स व्हाई वी आर डूइंग इट. जनरली दे आर नॉट प्रेजेंट ऑन ए नॉर्मल शिप.
ओके
सर, ये अनसिमेट्रिकल पेयर ऑफ हॉरिजॉन्टल सॉफ्ट आयरन, ये मेरा भी वही क्वेश्चन था कि अभी तो जैसे कि लाइक हॉरिजॉन्टल वेब फ्रेम अभी के टाइम पे या तो वॉरशिप हो या मर्चेंट शिप हो, दे ऑल हैविंग द वेब फ्रेम्स लाइक horizontal soft iron, so it is a like possibility all is zero for the A correction coefficient.
That's right beta, that is right. This is not usually present on normal merchant vessels, but we have to study it because the study of the compass consists of all possibilities which can be there.
Yeah, and also for the MMD also, they if they can ask the, so we can say the symmetrical and unsymmetrical type.
Certainly beta, certainly. If they ask coefficient A, we will need to explain this.
Yes, of course. Thank you, sir.
Okay, let me go further into detail. Now let's try to understand if we have such a configuration of horizontal soft iron on board a ship, so these kind of structures are present. How do they result into a real A coefficient? Or in other words, how do they generate a deviation which is constant irrespective of the heading of the ship? Whichever heading the ship goes, the deviation generated by these structures remains constant and does not change. So let us try to understand it. Now this is understood by making a deviation diagram. For every coefficient, we will be making a deviation diagram like the one you see on the screen now. We have the ship on different headings: north, northeast, easterly, southeast, south, southwest, westerly, and northwesterly. So cardinal and intercardinal heading, the ship is shown on these 8 headings. And in each of these headings, we are going to analyze that how do these horizontal soft iron structures, it is an unsymmetrical pair of horizontal soft iron structures, they generate the deviation which does not change. So we will first try to understand how do these structures affect our ship, and second we will try to see that how does this effect remain same irrespective of the heading of the ship. So let's try to concentrate our attention with the ship on the northerly heading. The ship is on a north heading. You can follow the laser pointer. This is the diagram which we are going to see or understand in detail. Now the ship is on a northerly heading. We have these two soft iron structures, one a athwart ship beam which is only present on the port side of the compass, and we have a fore and aft longitudinal which is present on the starboard side only forward of the compass. It is not present aft of the compass. So we have combination number one which we saw in the previous slide, a unsymmetrical pair of horizontal soft iron structures. You see this big blue color rectangle on top. This represents the north magnetic pole of the Earth. We are aware that the north magnetic pole of the Earth has blue polarity. And you see this red color rectangle at the bottom. This represents the south magnetic pole of the Earth, and we are aware the south magnetic pole has a red polarity. Now we know that the magnetic lines of force, they come out of the red pole and they go into the north pole. So the magnetic lines of force coming out of the red pole going into the blue pole. So in this particular diagram, you will see that the magnetic lines of force are going vertically upwards from the red pole to the blue pole of the Earth, going vertically upwards like this. Now with the magnetic field of the Earth going vertically upwards, it will affect both these structures. It will affect the fore and aft longitudinal also, and it is going to affect the athwart ship beam also. Now first thing to understand is that these are soft iron structures, so they do not have any permanent magnetism. There is no permanent magnetism in these structures. But being soft iron structures, they can get induced by the magnetism or magnetic field of the Earth. Now the magnetic field lines are going vertically upwards. If you concentrate your attention to the athwart ship beam, this athwart ship beam is not oriented or aligned in the direction of the magnetic field. It is at right angles to the magnetic field of the Earth. And if you remember during induced magnetism, I told you that there is minimum induction or zero induction, negligible induction when the soft iron structure is misaligned with the inducing field. The inducing field in this direction is in the north-south orientation, and this athwart ship beam is in the east-west orientation. The vessel is heading north, so the beam is in east-west orientation. So this beam is at right angles to the inducing field or the magnetic field of the Earth. Now being at right angles, no induction happens. No magnetic field induction happens here, and the athwart ship beam does not acquire any magnetism. There are no poles which are generated. Let's now concentrate our attention to the fore and aft longitudinal. The fore and aft longitudinal, if you look carefully, is aligned exactly in the same direction in which the Earth's magnetic field lies. The magnetic field lines are in the north-south orientation. The fore and aft longitudinal is also exactly in the north-south orientation. So the fore and aft longitudinal is perfectly aligned with the magnetic field. And this tells us that there will be maximum induction in the fore and aft longitudinal. Maximum induction. So we know the fore and aft longitudinal having maximum induction will become a strong magnet now. Let us now understand the direction of the poles which are generated. We see the magnetic field lines are coming out from the red pole of the Earth and going into the blue pole. So this tells us that these magnetic field lines will be entering into the aft end of the longitudinal. If they are entering into the aft end of the longitudinal, wherever the lines of force enter, that end gets a blue polarity. Wherever the magnetic lines of force are entering, that end of the magnet has a blue polarity. So that's why you see the aft end of the 4.5 longitudinal has a blue magnetic pole. And these lines of force going from south to north will be coming out from the forward end of the longitudinal, the forward end. Since they are coming out of the forward end of the longitudinal, you will see that the forward end of the longitudinal acquires red polarity. So this is the reason why you see in the diagram, the aft end of the longitudinal has blue polarity and the forward end of the longitudinal has red polarity. So we now understand the different poles generated on the fore and aft longitudinal. Now we have understood the induction or induced magnetism of the horizontal soft iron structures by the Earth's magnetism. Let's now try to see that at different headings, what is the deviation which is generated because of this induced magnetism. So as you can see in the diagram, at every heading, they indicate to us that it is a easterly deviation. You see north heading, northeast, easterly, southeasterly, southerly. On all the headings, they are denoting that the vessel has a easterly deviation. And in the definition of coefficient A, we have seen that it generates a constant deviation irrespective of the heading. So we will try to see now how does this deviation remain constant over all the headings. Let's first of all try to understand how this easterly deviation is generated with the ship on northerly heading. So what I'm going to do is I'm going to zoom in into this diagram with the ship heading north. We are aware that we have a 4.5 longitudinal and a outward ship beam. There is no induction on the beam right now because it is at right angles to the Earth's field, and there is maximum induction in the 4.5 longitudinal. So let's now try to zoom in into this. So here on the left side, you see a zoomed in diagram with the ship heading north. Let's first make the magnetic compass on this ship. Now we know the magnetic compass is basically a magnet, and the end which points towards the north is the red end of that magnet. So let's show our magnetic compass. You can see it here. The north end of the magnetic compass is having a red polarity. You see the red color, and the south end is having a blue polarity. So this arrow which you see in the zoomed in diagram of the ship now represents the magnetic compass. And we have a longitudinal which is to the starboard side of the compass, and it is forward of the compass location. It is not present aft of the compass location. So you can see this longitudinal in the zoomed in diagram now, and it is to the starboard side of the compass and is extending to forward of the compass. Now we have already seen that this particular end, the aft end of the longitudinal, acquires a blue pole, and the forward end of the longitudinal acquires a red pole. This is a soft iron structures, and these poles are acquired as induced magnetism, which are generated by the magnetic field of the Earth. Now, whenever we bring a magnet close to our compass, every magnet has two poles, a red and a blue pole. We cannot have a single pole in a magnet anywhere. Even if you break up a magnet, the broken ends immediately acquire the polarity. You cannot have a single pole at any point. Now, whenever you bring a magnet close to the compass, it has both the poles, the red as well as the blue. Now, which of the poles is going to affect the compass? Always, in all the conditions, that poles affect the compass which is closer to it. Because as you go far away from the pole, the magnetic field or its strength or its power reduces. It is inversely proportional to square of the distance. means if you increase the distance by twice, the magnetism or magnetic field strength of the pole goes down by 1/4. So whenever you bring a magnet close to the compass, that particular pole which is closer with respect to the other has its effect on the compass. Now in this particular case, the longitudinal is having two ends. One of the ends is very close to the compass, which is having a blue polarity, whereas the other end, for clarity, I have exaggerated a bit and taken it out of the ship's hull. So the other end of the longitudinal is close to the bow of the ship, which is much farther away as compared to the blue pole. So in this case, blue pole is the one which is going to have its effect on our magnetic compass. Now, how does this blue pole affect our compass? The effect of this blue pole onto the red end, that is the north end of the compass, will be attraction, because we are aware that opposite poles of a magnet attract each other. So this blue pole of the fore and aft longitudinal is going to attract the north end of our magnetic compass or magnetic needle. So when it attracts the north end towards it, the compass is going to deviate to the right side. Looking at the diagram, it is going to deviate to the right side, and that is easterly side. With the vessel heading north, the right side is easterly direction, so a easterly deviation is generated. Also, you can see this blue end is also going to interact with the south end of the compass. The south end of the compass also has a blue polarity. Now we know that the same poles of the magnet repel each other. So this blue pole of the longitudinal is going to repel the blue pole or the south end of our magnetic compass, again generating easterly deviation. The compass needle is going to swing clockwise, which is easterly deviation. So that is why you see they have mentioned here as easterly deviation. So beta, have a look now. Let me know your doubts. Clear, beta?
Sir, sorry, there's some issue with my Teams. Can I log out and log in again?
Yeah, please do that, beta. So no more doubts, beta.
सर ये सेम एग्जांपल आप ये सेम एग्जांपल नॉर्थ वेस्टर्ली हेडिंग पे प्लीज शो कर सकते हैं?
Okay, I'll show you on 3 headings, beta. I'll show you on easterly, then northeasterly. Remaining ones you can practice on your own.
Okay.
मैं अभी आपको लेके जाता हूँ. I'll take you to the easterly and then northeasterly. Okay, let me take you to other heading. Let us now try to understand the deviation generated on 090 heading. We take the ship on 090 heading and we try to understand what is the deviation generated. Now you see when the ship is heading 090, the fore and aft longitudinal is heading in the east-west direction and it is now perpendicular to the Earth's magnetic field. Earth's magnetic field is in the north-south orientation. With the longitudinal in the east-west orientation, it is at right angles to the Earth's field and it is totally misaligned with the inducing field. That is why no induction on the fore and aft longitudinal. On the other hand, the outward ship beam is now perfectly aligned with the magnetic field of the Earth. The Earth's magnetic field is in the north-south orientation. The outward ship beam is also in the north-south orientation. Perfectly aligned, it generates maximum induction. So you see onto the starboard end of the beam, a blue pole is generated, because this is where the lines of force are entering. The lines of force come out from the red pole of the earth and they go into the blue pole of the earth. So the starboard end of the outward ship beam acquires a blue polarity and the port end of the outward ship beam acquires a red polarity. Now to see its effect, let us now zoom into this particular diagram of the ship. We can zoom in and see the effect in detail. You can see the zoomed in diagram on the left side now. The vessel is heading in the easterly direction. The fore and aft longitudinal does not have any magnetism, so that's why it is not shown in this diagram. There are no poles generated there. The outward ship beam is present forward of the compass only on the port side. You see, it is unsymmetrical, so it is not present on the starboard side of the compass, it is only present on the port side of the compass. Being unsymmetrical was a requirement of generating real A deviation. Now we have seen the south end of the outward ship beam acquires a blue polarity. This is where the lines of force are entering. And the north end of the outward ship beam acquires a red polarity. Now the north end of the beam is close to the ship side and is far away from the compass, whereas the south end of the outward ship beam is very close to the compass location. It's very close to the compass location. So blue end is what affects our compass. The ship is heading in the easterly direction. Compass always points in the north-south direction. So compass is pointing in this particular direction only. And we have a blue pole to the east of the compass. This blue pole attracts the red end or the north end of our compass needle, and the blue pole repels the blue end of the compass needle or the south end of the compass needle, again making the needle swing clockwise, generating a easterly deviation. So you can see again a easterly deviation is generated. So whether the ship is on north heading or the ship is on easterly heading, in both the cases easterly deviation is generated.
सर ये पोल्स या जो रॉड हम जो बोल रहे हैं, अगर वो कंपास के पीछे होते तो ये ईस्टर्ली नहीं जाता ना, मतलब वो एंटी क्लॉकवाइज जाता.
That's right, beta. It depends upon the structures. अगर यही compass के aft में होता, it would have generated westerly deviation, but then it will remain westerly on all the headings.
ओके, बट तब उसको हम वेस्टर्ली डिवीजन बोलेंगे या फिर ईस्टर्ली डिवीजन ही रहेगा वो?
Okay.
जैसे आप बोल रहे हैं कि रियल
No,
ए
I'll
जो
tell
है
you, I'll
दैट इज
tell you.
ऑलवेज.
Just hold on. अब बेटा ये जो कॉम्बिनेशन मैंने आपको दिखाया है ना लॉन्जिट्यूडनल एंड ऑथवर्ड शिप बीम का, दिस इज वन पॉसिबिलिटी फॉर जनरेटिंग रियल ए. देयर आर मोर पॉसिबिलिटीज ऑल्सो. There are more possibilities also. For example, the outward ship beam can be aft of the compass and the fore and aft longitudinal can be on port side of the compass, forward of the compass. So there can be many possibilities for generating real A. So it will vary from possibility to possibility, but whatever deviation is generated on one heading, it will remain the same on all the other headings. Now you ask your doubt.
सर ये जो नॉर्थ एंड जो आपने शिप के आउटवर्ड दिखाया है उसको एक बार फिर से बता दो, वो क्लियर नहीं हुआ.
सिर्फ क्लैरिटी के लिए दिखाया है बेटा, अदरवाइज जो बीम है वो तो शिप साइड पे जाके खत्म हो जाएगा. मैंने क्लैरिटी के लिए उसे दूर कर दिया है सो दैट इट डजंट डिस्टर्ब योर अंडरस्टैंडिंग.
ओके.
सो नॉर्थ ईस्टर्ली हेडिंग पे चलें बेटा.
Sir, just one question. In the diagram on the right side, there it is getting a little confusing for me because it's showing the red pole of the compass and the red pole of the athwart ship
Exactly,
beam.
beta.
That
I
is both
agree.
red.
I agree, Abhishek. That is why I am showing you the zoomed in diagram. Book में right side वाली diagram है, which is confusing. That's why I'm showing you the
Yes, sir.
zoomed in diagram.
Okay, so in the exam, if they ask this question, so should we, I mean, how do we make that? Because it can be looked up as
Very
it's wrong.
simple. I'll
See,
tell you. I'll tell you. When you
yes, sir.
make the longitudinal, make it going up to the ship's port beam. Touch it with the ship's port beam, so then it will make it clear to the paper checker that the red pole is far away and the blue pole is close.
Okay, sir. All right.
Okay.
Sir,
So
Ashish,
let's
sir, please
go ahead.
repeat your last sentence, sir.
Which one, beta? How to show that in exam diagram?
Yes, sir.
Okay. बेटा ही हैड ए डाउट कि जो रेड पोल है ये भी उन्होंने कंपास के पास बना रखा है, जो राइट साइड वाली डायग्राम है, तो आप इसको दूर बना सकते हो. मेक द रेड पोल क्लोज टू द शिप साइड. पोर्ट बीम के पास इसको बना दो. एग्जामिनर विल अंडरस्टैंड देन.
Yes, sir. Perfect.
ओके. और जैसी ये zoomed in डायग्राम मैंने बनाई है, आप ऐसी भी बना सकते हो, बट इसको बनाने में या यू कैन मेक इट लाइक दिस. जैसी zoomed in डायग्राम में देख रहे हो आप, यू कैन एक्सटेंड इट अ लिटिल बिट आउटसाइड आल्सो, नो इश्यूज.
Perfect, sir.
Okay, let me take you to northeasterly heading, beta. Northeasterly, let's go. Now let's see a third scenario with the ship heading in the northeasterly direction. So with the ship heading in the northeasterly direction, how does the deviation behave? Let's zoom into this diagram of the ship. So on the left side, you see the zoomed in diagram of the ship. We have the compass as usual placed in the center line. Irrespective of what is the direction in which the ship is heading, the compass needle is always going to point north and south. The north end will be the red end of the compass and the south end will be the blue end of the compass. Now we have a longitudinal, fore and aft longitudinal to the starboard of the compass. So you can see on the starboard side we have a fore and aft longitudinal which is only forward of the compass. It is not there aft of the compass. We also have a athwart ship beam. The athwart ship beam is forward of the compass and only to the port side. You can see the athwart ship beam is only to the port side of the compass. It is not present on the starboard side. Now I have taken the far ends of the longitudinal and the beam out of the ship's hull just to make the picture a little more clear and easy for understanding. Now in this case you see the Earth's magnetic field coming from south to north is going to induce both these structures because both of these structures are now at a 45-degree angle to the Earth's magnetic field. They are neither fully aligned nor misaligned. They are partially aligned with the magnetic field of the Earth, so there will be partial induction on both these structures. That is the longitudinal as well as the beam. Partial induction on both of them. So the poles generated will have partial power. And now you look carefully. The blue pole is generated in the longitudinal as well as the beam. And this is the pole which is closer to our compass. The red poles generated are far away from the compass. So blue poles are the one which are going to affect our compass. Now the blue pole of the athwart ship beam is closer to the red end or the north end of the compass and it is going to attract the compass towards it. Whereas the blue pole in the longitudinal is close to the south end of the compass, which is again blue, and both being the same polarity, they are going to repel each other. And you will see, even though there are two poles, they are both trying to swing the compass in the clockwise direction again. So you see the compass has to swing clockwise again, generating easterly deviation. Now, one doubt may arise that since there are two blue poles now, the deviation generated will be more powerful, but that is not the case. Reason being, even though two poles are generated, but both of them have partial power. Why the power is partial? Why their strength is partial? Because they are not perfectly aligned with the magnetic field of the earth. Both the longitudinal and the outward ship beam are partially aligned, making these poles partially powerful. So when both these poles add up, they generate the same easterly deviation which was generated on 000 heading and 090 heading. So you can see, irrespective of the heading on which the ship is, the deviation generated remains the same. So beta, you can ask your doubts now.
Sir, if the vessel, the real A deviation is generating the easterly deviation, that means the amount of the deviation will be same at every point.
At every heading, beta, it will be same.
Yeah, at every heading the amount of the deviation will be same because of this blue poles, they are, if दो अगर दो भी है तो भी उसमें equally वो distribute हो जा रहा है, और एक है तो उसमें भी एक में उतना power है, तो सारे point में तो एक ही point एक ही होना चाहिए ना सर.
That's right, beta. That is why you see coefficient A is independent of the ship's heading. Wherever it goes, wherever heading the ship goes, the deviation due to A remains the same.
Okay, sir.
सर ये rods अगर like जो rods हैं अगर same length के रहेंगे but एक forward में है एक aft में है, then we can call them unsymmetrical.
Okay, now beta you are right. हमें पता है कि compass जो है it is usually present at the aft of the ship and the forward part is longer for a longitudinal, aft part will be shorter. Also एक दूसरी चीज भी यहाँ पे है कि longitudinals are longer in length and outward ship beams are smaller in length. So दोनों में थोड़ी बहुत difference of power तो आएगा. Because the longer a structure is, the greater induction, maximum and more induction will be there. But in compass, we neglect this difference because if we go into details of this difference also, it becomes very complicated. So we consider the effect of the longer longitudinal same as the outward ship beam. So we neglect this effect.
Sir, if in an exam
Okay,
they are
but
asking
sir,
about the
मेरा
A
question,
deviation. Sir,
बोलो बेटा.
sir, in an exam, if they are asking about the A deviation and we are making this figure and explaining what we have understood, will be enough?
Enough बेटा. अभी मैं एक दो चीजें और आपको बताऊंगा, वो भी explain कर देना. That's enough.
Okay, sir. Thank you.
बेटा अभी के लिए तो बड़ा सिंपल क्वेश्चन है, एक्सप्लेन कोफिशिएंट ए. उसका आंसर अभी कंप्लीट नहीं हुआ है, मैं अभी और चीजें भी आपको बताऊंगा.
Sir, so we have to explain each and about each and every heading, or just like three of them, three or four of them. In the
I would say write a line for each of them. Write a single line for each of them. Just
Okay.
no need to explain them in detail. You can explain 1, 2 and 3 in detail and remaining ones write a single line because आपको question 20 minutes में complete करना बेटा.
Right. Okay. Thank you, sir.
Okay beta, great. Let's move ahead then. Now remaining headings beta are exactly similar to what we discussed. So you can make a diagram yourself and you will be able to understand the deviation remaining same. So I'm not going into other headings now. So let's proceed. Now let's move on to the correction of real A. How do we correct this coefficient? The correction of real A is generally not attempted, not done. The reason for it is, number one, it is very rare on a normal seagoing merchant ship that a coefficient A will exist, because these kind of soft iron structures are not present on the ship. Whatever soft iron structures are present, they are symmetrical about the compass location. Even when it is present in some ship, it is likely to be very, very small. So this is the reason why we do not attempt the correction of real A. What is done then? Since the deviation generated is constant on all the headings, it can be applied as an index error. So you will see that on a ship where real A is present, the real A value will be mentioned separately in the deviation card. Like, let us say, for example, the deviation card will tell you that the real A correction or index error correction is 1 degree east. So whatever deviation you obtain from the curve, you add 1 degree east to that deviation and it will give you the resultant deviation. So deviation being constant on all the headings, is it applied as a index error and the real A is not generally corrected. Is that clear, beta? Any doubts?
Clear.
Very good, beta.
Sir, can you repeat this one because my connection got lost?
No issues, beta. The correction of real A is not attempted because it is very rare on a ship that coefficient A will be there. Even if it is present, it is very, very small. So we apply this correction even if it is there as a index error. You will see it written on the deviation card, index error 1 degree east or coefficient A 1 degree east. So you apply it on any heading and correct the coefficient A. Okay, great. Let's move ahead. Now the second component of coefficient A, which is known as apparent A, is basically the constant deviation on all headings caused by factors other than the magnetic field. So any reason, any cause other than the magnetic field which leads to a constant error on all the headings will come under apparent A. There can be numerous reasons for generation of apparent A. Some of the examples, some possibilities which could lead to this kind of an error. You can have the magnetic needles of the card not parallel to 180 degree direction of the card. Now this is a manufacturing defect. You can visualize a card is being printed. The magnets are to be fitted exactly in the 000180 direction. But if during the construction of the card, the magnets are fitted slightly at an angle, let us say 002 and 182 direction. So there will always be a slight error which the compass will show. This has got nothing to do with magnetism. So this falls under apparent A. That's a manufacturing defect in the card. Sometimes we see there is a lubber line which is fitted on the repeater. If the lubber line is not parallel to the ship's fore and aft line, so whenever you read that lubber line to get the heading of the ship, there will be a constant error. This has got nothing to do with magnetism, and it's also a manufacturing defect, so it falls under apparent A. Other reason could be constant error in observing the bearings when the compass is initially adjusted. For example, there could be an index error in the azimuth mirror leading to wrong deviation card. So when that wrong deviation is applied, you will get an error. So that's also a non-magnetic reason. Further reasons could be error in computing the magnetic bearing when the compass was adjusted, rapid swinging of the vessel when observing the bearing for compass adjustment. It is recommended that whenever we are doing the compass adjustment, the vessel should not be swung rapidly. It should be steadied on a particular heading before noting down the deviation. Or R angles worked out wrongly leading to error in the calculated bearing. we usually obtain the compass error by using the azimuth, calculating the azimuth by ABC method. So if the method has been worked out wrongly, it will lead to a wrong deviation being noted down. And if we use that wrong deviation, it will give us wrong bearings or wrong heading of the ship. So there could be many other reasons also. Any reason other than magnetism which leads to a constant error on all the headings falls under the category of apparent A. So is that clear, beta? Any doubts? Very good, beta. Excellent. So we are, yeah, let me show you one more thing and then that will finish the coefficient A. Now, how do we calculate the coefficient A for the correction purpose? The value of coefficient A can be easily obtained as the mean of deviation on at least 4 equidistant headings. What does that mean? Let us take the ship on a northerly heading and note down the deviation. Let's now take the ship on a easterly heading, note down the deviation, then southerly heading and westerly heading. So all the 4 cardinal headings, we swing the ship, take it to 4 cardinal headings, and we note down the deviation on these 4 headings. Now, once you take a mean of these 4 deviations, it gives you the value of coefficient A for that particular ship. Practically, this is done using 8 deviations on cardinal and intercardinal headings. Taking this value in 8 deviations gives you more accuracy. So practically we use the deviations on cardinal and intercardinal headings and take a mean. Now you can easily test out this method or try out this method using this formula. This is the same formula which I showed you. Deviation is equal to coefficient A plus B sine cos plus C cos cos plus D sine 2 cos plus E cos 2 cos. So in this formula, if you put the cos as 0, 0, 0 and get the result, then second time you put the value as 90, third time you put the value as 180, fourth time you put the value of cos as 270. Now once you get the answers and you take a mean, you will see that all the other coefficients B, C, D and E will get cancelled out. The only coefficient which will remain is coefficient A. So once this is calculated, then the compass adjuster can write this as a index error if it is present on a ship. So any doubts up to here, beta?
Can you explain the last part, sir? The Formula 1, like how are they getting cancelled out?
Okay, try this out, beta. You write down this formula first with course 90, second time with course 180, third time with 270. And sorry, 0, 90, 180 and 270. For all these 4 courses, just note down this formula. You will get 4 equations for deviation. Take a mean of them, add all 4 of them and divide by 4. All these coefficients, Bravo, Charlie, Delta and Echo will get cancelled out. What will remain is only coefficient A.
Okay, understood. Okay, sir.
सर स्टिल आई डोंट अंडरस्टैंड कि ये ए का वैल्यू अभी अगर ये फॉर्मूला में डालना होगा तो ए बी सी डी का वैल्यू मुझे कहाँ से मिलेगा सर? साइन कोर्स तो अभी भी मुझे मालूम है कि कोर्स मुझे हेडिंग से मिल जा रहा है, बट ये वैल्यूज कहाँ से लाऊंगा सर ए बी सी का?
बेटा आप शिप की डेविएशन नोट कर सकते हो?
यस सर।
आपने 4 कार्डिनल हेडिंग पे शिप की डेविएशन नोट कर ली।
ओके।
आपने उनका मीन ले लिया। मीन मीन्स add all of them and divide by 4. You will get a value.
Okay sir.
That is what is coefficient A of that ship.
Okay. ये कोफिशिएंट ए हो गया उस मतलब फॉर्मूला के अंदर जो ए का वैल्यू बैठेगा उसका उसका डिजिट है ये.
Yeah, you calculated the coefficient A on your ship practically. So that is what it is.
And what about B, C and D, sir?
We will be doing it now.
Okay, sir.
Okay.
सर
Okay,
ये
बेटा.
apparent A का हम कोई करेक्शन अप्लाई कर नहीं सकते बिकॉज मैन्युफैक्चरिंग डिफेक्ट है. रियल A could be like we can use it as a index error और नए जहाजों पे ये होता नहीं तो रियली इस फॉर्मूले का फिर मतलब ही क्या हुआ सर?
You mean okay, बेटा एक बार दोबारा what is the question you are asking? That what is the use of this formula?
हाँ एग्जैक्टली देखिए ये रियल ए जो है वो अभी के जहाजों पे होता नहीं और पुराने जहाजों पे भी बहुत ही मिनिमम होता था. इंडेक्स एरर एज ए इंडेक्स एरर वी कुड हैव यूज्ड. ठीक है. एंड देन अपेरेंट ए है उसमें हम कुछ कर नहीं सकते बिकॉज वो मैन्युफैक्चरिंग डिफेक्ट है.
ओके.
तो बेसिकली हम अपेरेंट ए हम पढ़ ही क्यों रहे हैं और इस फॉर्मूले में ए का फिर यूज ही क्या हुआ जब नए जहाजों पे है ही नहीं.
आई गॉट योर पॉइंट. इस फॉर्मूले से जो आप ए की वैल्यू निकालोगे ना बेटा, हमने 4 इक्विडिस्टेंट हेडिंग पे डेविएशन नोट की और उनका मीन लिया, हमारे पास ए की वैल्यू आ गई. दिस विल कंसिस्ट ऑफ एपरेंट ए एज वेल एज रियल ए. उसमें ये दोनों होंगे. ओके बेटा. और ये हमें फॉर्मूला यूज क्या दे रहा है? जो ये मेथड हमने फॉलो किया बेटा कि हमें 4 इक्विडिस्टेंट हेडिंग पे मीन लेना है, वो एक्चुअली इसी फॉर्मूले से निकल के आया है. दिस मेथड हैज कम आउट फ्रॉम दिस फॉर्मूला ओनली.
ठीक है सर. ओके.
ओके. एनी मोर डाउट्स बेटा? Okay, great. So I'm closing this now beta. Coefficient A is completed.